Hello folks, we come to the part 3 video of this exercise 7.3 and we'll be continuing with the problems that we had left last time. Last video we had finished the 6th question, so henceforth we can start with the 7th question and so on. Now what does the 7th question say is, they give us an equation and they ask us to find the value of r from here. So we have to use the p definition. NPR is equal to n factorial by n minus r factorial. By using that definition, we are supposed to find out the r value in the subpart 1 and 2. That we will do, and then we will be moving on to the next question if possible. So let's see now how we can apply this over here. By definition, NPR we know is n factorial by n minus r factorial. So this comes here. There is a 2 here. There will be 6 factorial here. Then 6 minus r minus 1. N minus r. That's how we do it. So it is 6 minus r plus 1. So it will be 7 minus r. Now for the simplicity of working, let's have the numbers on one side and let's have the r's on one side. So we'll have 5 factorial here and the 6 factorial can come here from there, and 2 is there. Let the 5 minus r factorial go there. It is 5 minus r factorial by 7 minus r factorial. We have learnt all the permutation shortcuts which will help us to solve easily and get the answers maybe faster. So therefore here writing 6 factorial is as good as writing 5 factorial into 6. Similarly, from these two numbers, 5 minus r factorial and 7 minus r factorial, 5 minus r factorial is a smaller number and 7 minus r factorial is a bigger number. Now how you will judge that is, you can at random put some value of r. Like for example, suppose if you put r as 2 or something, substitute. So 5 minus 2 comes to 3 and 7 minus 2 comes to 5. So that means it's like 3 factorial and 5 factorial, which means whatever is there in the denominator is a bigger number. So in order to solve that, we will write 7 minus r factorial as 5 minus r factorial into 6 minus r into 7 minus r by the rules of permutations, because we have decided which is big and which is small. Now what happens is all this can be cleared off, and then we can have this term coming here and this term going there so that we can solve it. So what will come here? You will have 6 minus r into 7 minus r coming up here, and this is 2 into 6. We have got it cleared like that. So we can open the brackets. 42 minus 6r minus 7r plus r squared is 12. Obviously, we would have to solve this quadratic in order to get the value of r. So let's have everything on one side. So r squared is here. This is minus 13r plus 42 is here. The plus 12 from the other side can come here to become minus 12. So what will happen? This is r squared minus 13r plus 30. So evident, this breakup. 30 means 3 into 10 and 10 plus 3. So both will work. So you will have r squared minus 10r minus 3r plus 30 to be equal to 0. So when we factorize, you'll get r minus 10 into r minus 3. Each of them have to be 0. By all that logic, you will get r values as 3 and 10. The values of r that comes up here is 3 and 10. Same idea we have to use in the next problem also. Minor variations are there over there. So we will see how we can do the next problem also. So same idea. This is now 5 factorial by 5 minus r factorial. This is 6 factorial by 7 minus r factorial. Just like how we did there. In this case there's a 2, in this case there's no 2. That's all. But remaining working is all identical. So you have 5 factorial by 6 factorial here. 5 minus r factorial by 7 minus r factorial. Earlier we have decided this is small, this is big. So we are going to make the permutation ideas we are going to use, and we are going to see how this is. This is like 5 minus r factorial into 6 minus r into 7 minus r. And then we have maximum things are getting cut. So you have 6 minus r into 7 minus r, and here is that 6. When you open it up, 42 minus 6r minus 7r plus r squared is 6. We have everything on one side. Minus 13r plus 42 minus 36, it's plus 36, which is 0. 36 is 9 fours are. So you can have 9. See, 36 other things are there. 6 6 is there, 9 4 is there, 18 2 is there. But what is working for us is 9 and 4. So we are taking those as a factors. Plus 36 is equal to 0. Then our normal split up gives us 9 minus r, 9 minus 4, sorry, r minus 9, r minus 4, and the r values therefore work out as 4 and 9. Earlier case it was 3 and 10, in this case it is 4 and 9. That is about our value of r. And that is our question number 7. Let's check if we can go to question number 8 and see what it says. Question number 8 says that how many words with or without meaning can be formed from the letters of the word equation using each letter exactly once. So you can pick up the alphabets from this word equation and then you can form different words out of it. So in how many ways you can do it? That is a question. So you pick up all the alphabets and arrange it haywire, however you want, you arrange it and get different types of words. How many such words are possible is what the question is. So first, whenever you're doing a permutation problem, you have to make two things clear. First is your choices available. Second is the places you need to fill. So once this is clear, you just have to put the P definition and get the answer. Now, because they are asking us to form use all the alphabets of this word equation to form a new word, it is basically 1, 2, 3, 4, 5, 6, 8 alphabet word. So therefore we have we have to fill 8 places. And how many choices we have? We have 8 choices. We have got these 8 alphabets. They have allowed us to use these 8 alphabets to fill the 8 places in whatever way we want. So what we are doing, out of the 8 alphabets, we are filling the 8 places. In how many ways we can do it? We can do it in 8p, 8 ways. That's all. And another shortcut is npn is always n factorial. So that also goes up directly. So that's all that we have to do over here. So we can say here, the given 8 alphabets has to be used to fill the 8 places. Therefore, number of ways of doing this. Is 8p8, and we don't go in for any calculation because we know that npn is n factorial. So that way it is 8 factorial, and those of us who have memorized 8 factorial, I think we can write it directly, otherwise we will multiply and get the answer. If my memory goes right, I think it is 40320. Let me check if my memory is correct. Yes, 40320. I've managed to memorize it till 8 factorial, 9 factorial, 10 factorial is slightly difficult still to memorize, but till here, yes, 7 factorial is 5040 if I'm not mistaken. Yeah, so that's about the 8th problem. 9th problem, whether we can do it, no. So 9th problem onwards, maybe we can take it up in the next video. So that is about this. This is our part 3 video. Part 4, we will take the next 2 problems. Thank you.